Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Solving equations and inequalities by graphing. I understand many of you just groan at the word graphing. However, it does have its usage for those of us who are visual learners. Now, for example, something such as 4x minus 3 equals 5, you might be able to do off the top of your head. And I know many of you would go, well, you just add 3 and divide by 4. And that is correct for an algebraic approach. So for a graphical approach, let's go ahead and let's look at this. We are going to look at the left side and the right side as two separate equations. We're going to graph the left side, and then we're going to come back and we're going to graph the right side. For many of you, the right side might be easier to graph. It is a constant equation. The slope is 0. So we are going to go up 5 spaces. And with the slope being 0, we're just going to draw a constant flat line that goes on forever in both directions. Not so bad to graph. Many of us are very good at graphing these. The number that's by itself is -3, so I'm going to start on my y-intercept at -3. And the number in front is 4, or we can change it to 4 over 1. And that is going to be our slope. So our rise and our run, our rise and our run, up 4 over 1, and we will connect those. Now, if you happen to notice, the pink line intersected the green line. What x value did they intersect at? X equals 2. And that is our solution to our original equation. What value would make this statement, that's what we call a mathematical equation like that, true? And the answer is 2. Because 4 times 2 minus 3 is indeed 5. It verifies. You might notice that there's an ordered pair that this meets at. It meets at the ordered pair 2, 5. We are not interested in the y because the y is not included in the problem. The only information we really need is that x is 2. So from graphing, we found out that x equals 2. Some of you might go, okay, yeah, I could have done that in my head. You're right. I'm sure you could. You're awesome. However, what happens when the problems become a little bit more challenging? Can you do absolute value equations in your head? Now we've had an interesting conundrum because, hey, the last one was pretty easy, but this one's a bit more complicated. Some of you might be able to do it in your head. For those of you who are not that talented, we're going to go ahead and look at graphing these. And we're going to graph the linear side first. We will graph the linear side in light blue. So our y-intercept is -1, and our slope is -1 over 2, or -1 over 2, down 1 over 2, down 1 over 2. And we could keep going. I'm going to back that pattern up, put it in reverse. That way I can get a nice long linear equation image. I drew that a little bit freehand, so if I have to go back and adjust it, I will. Okay, so our parent graph is an absolute value. Absolute values make V's. It's been moved left 2, up 3, and reflected. Again, the order of operations that happens in is left 2, reflected, and then moved up 3. So left 2, flipped over the y-axis, and then up 3. Sorry, I said y-axis, I meant x-axis. And it's going to make that D shape. The slope is not changed, so it is a 1, 1 shape. Okay. Now that I have the graph, I notice that the blue line meets the pink line twice. So, again, I'm only worried about the x values because only x was included in this statement. So I need this x value and this x value. So from the origin, -1, 2, 3, 4. 1, 2, 3, 4. Will they always be the same number like that? No, they will not. I've seen examples where they are different numbers, very, very different numbers. Just happened to work out this time. So again, the graphing allowed us to visualize that there were 2 answers to this. Now let me switch that up for you. They might ask other questions as well, and we can use this graph to still help us. Negative absolute value of x plus 2 plus 3 is less than -1/2 x minus 1. Now remember, the absolute value we put in pink. When is the pink less than the blue? Okay. In this section over here, and then in this section over here, I would say the pink is less or lower than the blue. But since we only work with x's, we can only talk about the x values using that domain, those walls. Again, I've talked about the walls multiple times in several videos. So for this section, where the pink is lower than the blue, the wall is at 4, -4, right? And we need to describe these x values. So between -infinity and -4, it is not underlined, so we cannot use it. Or, again, using the walls, 4 to infinity. So an inequality just refers to above or below, right? Pink below blue. That's what we can read that as. So it's very helpful. Let's try another inequality. -x² plus 9 is greater than or equal to 0. Okay. Let's remember that when you graph y equals 0, it is a flat line that crosses the y-axis at 0. So keep that in mind, that y equals 0 is technically the x-axis. And here we have a parabola. 1, 2, 3, 4, 5, 6, 7, 8, 9. Number 1. Okay, so the parabola I did in blue. We want it above or equal to the green. Okay, well, let's look at this. In this section, if I go to this ordered pair right here, the green ordered pair is higher than the blue. We want blue higher than the green. Here blue is definitely higher than the green, but then blue goes back lower. So it's only in this middle section here that the blue is higher than the green. And since we're only talking about the x's, we're only going to use those x values. And it's underlined, so we can actually use brackets. So our answer will be when x is between -3 and +3. And you can test different numbers if you want. Oh, what if x is -5? Notice how I substituted that? I've still put the parentheses around my input. I have the negative and the squared outside of it because they were written in the problem. That is not greater than 0. What about +5? Not greater than 0 either. Okay, so let's double check something in between. How about -2? That definitely is above 0, so we're good there. You can go ahead and use spot numbers to guess and check. However, I find when you have an inequality, solving by graphing is an excellent way to approach these problems because it gives you a nice visual and you can compare when one equation is higher than the other. So again, solving equations by graphing is just another method that you can have for just in case you get stuck using algebraic methods. Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Then drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.